Now we will try to find out the network addresses and broadcast addresses with the valid IP addresses in the class A. So first we will write the prefix 0 for class A and put 0 in all the hosts, and for broadcast address we will put all the ones in the host. So we get 10.0.0.0 as network address and 10.255.255.255 as broadcast address, and all the IP addresses between them are known as IP address that are valid and can be used in the network. Now same we will repeat with class B. Over here the prefix is 10 and we will put all zeros for network address and all ones for broadcast address in the host position. So here for class B we get 172.16.0.0 as our network address and 172.16.255.255 as broadcast address, and all the IPs between them are valid IP address which can be used in the given network. Now the same example for class C. Here the prefix is 110. So we get network address as 192.168.1.0 and broadcast address as 192.168.1.255. All the addresses between these two addresses are valid IP addresses which will be used in the network. The certain addresses are reserved for the LAN in the company or in the office or in other private networks which are not connected to the internet. Some of the IP addresses which are reserved for such purpose are listed below. Class A, that is 10.0.0.0 till 10.255.255.255. In class B we have from 172.16.0.0 till 172.31.255.255. In class C we have from 192.168.0.0 till 192.168.255.255. These all addresses can be used in the private networks, but these computers cannot be connected to the internet. Subnet mask is basically used to differentiate the network portion address from the host portion address. It has been given for the host identification of the network ID. It is represented with all ones in the network position and with all zeros in the host position. That helps to identify the network ID of any given IP address. Now we will try to find out the default subnet mask for class A, B and C. So to find out the default mask we will have to write 1 to the network portion and zeros to the host portion. So for class A it will be 255.0.0.0. For class B it will be 255.255.0.0, and for class C it will be 255.255.255.0. These are all the default subnet masks. Now we will try to find out the network ID from a given IP address and the subnet mask. Now first write in the binary form the given IP address and the subnet mask, and then end the two addresses. Now whatever the resultant you get after ending the two will be your network ID. So in this case we are getting 192.168.1.0 as our network ID. Subnetting is nothing but division of a single network into multiple subnetworks. That is nothing but converting the host bits to the network bits, that is from 0 to 1. It can also be known as fixed length subnet mask, and subnetting can be done in three ways: requirement of the network, requirement of the host, Cisco notations. Now we will see an example how to divide the networks. Now consider an example, say Zoom Technologies have 100 PCs. The preferred type of network will be class C. Now say suppose it has 5 departments, which each department having 20 PCs. We can divide them as the following: IP address 192.168.1.1 till 1.20, then from 21 to 40, 41 to 60, 61 to 80, 81 to 100. These are the 100 IP addresses required by the company. Now this is one way to do it. Now if we put any restriction like inter-department communication should not be possible, then we will have to allot different network to each department. In the previous case, the first three parts or the octets were the same, that is 192.168.1.1 till 192.168.1.100. Over here we are allocating a different network to the different departments. So these are the 5 departments. So here dot 1, dot 2, dot 3, dot 4, dot 5. Each network will have the 20 pieces starting from 1 to 20. So over here the communication between the two departments will not happen. So the advantage of the second case scenario is that it won't have to broadcast 254 machines instead of 20, because one department is not concerned with the other. All the broadcast message for the one department is useless for the other departments. We are approximately wasting 1000 IP addresses in the previous scenario, and there is no security for one department from the other. So we normally use the second scenario. These are just the table for your help during your calculations of the networks and the host. This is the power table. This has some important values for subnet mask, that is 255 is represented by this mask, and so on, useful during your calculations of number of hosts and the network. Now this is an example to divide the network by subnetting when the required number of network is 5. So first we will put the prefix for class C, that is 110, and starting address as 192.168.1.0. Now number of subnet masks is given by 2 raised to n minus 2. That should be greater than the required number of subnet. Over here that is 5. So we will put n is equal to 3. So over here we get 6 subnets, which is more than 5, so that is sufficient for our criteria. So now we will calculate the number of hosts for the same given scenario. That is 2 raised to 5 minus 2, that is 32 minus 2, which gives us 30 hosts per subnet. So over here we will get 30 hosts for each network. Total number of networks are 5. So this is the customized subnet mask for the previous sum. Over here we convert 3 host bits to the network bit, which in turn gives us 6 subnets and 30 hosts per subnet. So the range of the subnets is as given by the following IP addresses. Like consider this as the different departments. Like the requirement is 5, but the minimum number that we are getting is 6. So consider it as a 6 different departments with 6 different set of IP addresses, each network or department having 30 hosts. Now this is a similar sum with a slight change with network number as 14. So still we will take the same IP address as our starting address, and we will try to find out a subnet for 14. So over here we are getting equally 14 networks when we use n is equal to 4. Now number of hosts in this will be 14, which is less compared to the previous case, but we have more number of networks. So in this scenario we will be having 14 hosts per subnet. So now for 14 subnets and 14 hosts per subnet, we have to convert 4 host bit to the network bit. So the customized subnet mask becomes 255.255.255.240, and the 14 subnet range will be as follows, which are shown below. Thank you.